Hello everyone, welcome to the 5th episode of Case Done by AI Live. My name is Pisek, or you can call me Benz as well. At Case Done by AI, we aim to empower your business, your team, or as an individual, developers or AI researcher, we aim to empower your skills. So if you're interested to know more, subscribe to our channel, and better, tell your friends about us. So in today's episode, I have 3 very interesting topics to cover. The first one is about hiring the right LLM to build your app, and eventually it comes down to LLM evaluation. We will be looking into the Chatbot Arena, MT Bench, and the MMLU benchmark. On the second topic, we will be focusing on tokenization. It's an essential step to use the LLM. We will be actually looking into Token library, which is an open source library for tokenization from OpenAI. And the last topic, we are going to actually build a chatbot to chat with our customers. We will be using a technique called RAG, and in our case, we are pretending we are running a coffee shop. So you can see how the LLM or RAG technique can be applied to your business. In this case, a coffee shop store. You will actually see LangChain, Chroma, and Gradio at work. So let's get started. Hiring the right LLM for your application is essential. You want LLM that is capable, but you want to keep the cost down as well. Now that you see there'll be more models releasing every now and then, very often. As you can see from this plot, each plot corresponds to a particular LLM, and you can see it's getting more dense as we goes by. So we need a way to compare them, and we need a way to pick them to do the task that we want really well. But before we go into that, this is the website that has a beautiful representation of the LLM by year and by providers as well. So if we focus on OpenAI, we can filter it here. So yeah, since 2020, we know that here, this is a GPT-3. It's originated by that time, but it will be publicly available in 2021, I think. GPT-4 is right here, around the first quarter of 2023. GPT-5 is somewhere in the future. I hope it comes soon. Oh, 3.5 is right here at the beginning of 2023. This is when OpenAI has launched ChatGPT, I think. From Facebook, we have Llama 2, a well-known one from the Meta of Facebook. Llama 3 is somewhere in the future, we don't know yet. Anthropic is known for its Claude model. Yeah, it's a very popular Claude 3 model is right here. And the size, I think it's the number of the parameters of the model, right? And yeah, as you can see, it's getting denser and denser by the time. And oh, here we have Mistral Large from the Mistral camp right here. And the y-axis is the size of the model measured in the number of parameters in it. So this website also has an Excel sheet kind of, or Google Sheet format. So the thing is, in the future, we'll see more and more LLM for sure. And how are we going to pick the right one for us? So we need a way to evaluate those large language models. What I'm going to cover is work from LLMsys team. It's actually the LLMsys in collaboration with UC Berkeley Skylab. So Chatbot Arena, it's a way to evaluate. It's actually an evaluation platform that allows any user, human like us, to rate LLMs via pairwise comparison under real-world use cases. And LLMsys also provide open source tools. They call it a fast chat, which include front end for chatting with the LLM, and model serving at the back end and other evaluation tools as well. In the Chatbot Arena, if you go to its website, which I'm going to show, they have a full leaderboard in which there are 3 scores or 3 benchmarks. The first one is the Chatbot Arena itself, and the second one is MT Bench, and the third one is MMLU. I'm going to cover, or I'm going to explain what they are. The Chatbot Arena is a benchmark that human rates model A against model B, and when you have a lot of ratings, which models wins or is it a tie, we apply some methods to rank the model itself. So right now, or initially, the team started with ELO rating, but now it's migrating into Bradley-Turing model in the future. The second one is the MT benchmark. It's a technique that actually uses the LLM as a judge, rather than using human to judge against a model A against the model B. Now this technique uses LLM as a judge itself, and it's allow for a scalable approach to evaluate the LLM. And the last one is the MMLU. MMLU stands for Massive Multitask Language Understanding. It's actually a benchmark that is meant for testing the LLM for extensive world knowledge and problem-solving ability. Alright, let's start with the MT Bench. MT Bench, the motivation is, so we need to evaluate the LLM, right? And there are challenges associated with it. Some benchmark measured core knowledge, it requires the LLM to answer a short and specific answer to a prompt or questions, which is usually a 0 shot or few shot questions. So it's a closed-end kind of evaluation. But now that LLMs are getting larger, having more capability, it can answer to open-ended questions. So we need a better benchmark, or benchmark that can evaluate other capabilities. So in terms of the measurement, a conversational benchmark like Co-QA or Dialog or Open Assistance can evaluate an open-ended questions answering of the LLM. So MT benchmark is another approach or another benchmark proposed by LMSys and UC Berkeley, so that we can evaluate the LLM in that sense of capability. The technique is that in MT stands for multi-turn. So you are you are questioning the chatbot many turns, and this is getting difficult to evaluate. So they propose a technique called LLM as a judge. Essentially, we are going to use a large language model, very large language model like a GPT-4, to judge the responses of other smaller, hopefully smaller LLMs. There are many ways to do that. In the paper itself, the paper is actually here, this paper, judging LLM as a judge with MT Bench and Chatbot Arena. There are 3 ways to use LLM as a judge. The first one is pairwise. You are comparing model A against model B. The second approach is single answer grading. So you don't actually compare. You ask the LLM judge to rate a particular model's response by score, right? So eventually you get a single answer from the LLM, and you use the bigger LLM to rate that answer in terms of values, maybe 0 to 1, for example, and that will be the performance of this, the other model. The third one is reference guided grading. Yes. So you will need to provide reference solution, and then you ask the LLM to judge if the response of another LLM is better, or is it good with respect to the reference. Now, this technique, using the LLM as a judge, it has advantages in a sense that it's scalable. You are using AI as a judge. You don't need human anymore. Human judge can be expensive, slow, and not scalable. But now if you train an LLM, a very good LLM, to do or to work as a judge, now it's scalable and explainable. However, because we are using LLM as a judge, there are disadvantages from the LLM itself. The first one is position bias. The position bias means some LLMs are going to like the first answer better than the second answer. Now, taking in mind that you are, especially in pairwise comparison, you are comparing the response of model 1 against model B. Some of the models will like the first answer, maybe model 1 more. So this is position bias. Verbosity bias, it means that LLMs tend to like some kind of language or the way a concept is explained better than another type of language, or using other words to explain that language. So this is verbosity bias. The third bias is self-enhancement bias. Basically, the LLMs like its own answer. Let's say that you are using GPT as a judge, but now you are comparing a model A, which is maybe Claude 3, and model B, which is randomly it's GPT-4. So the GPT-4 is going to like GPT-4 answer, right? So that's what a self-enhancement bias is defined in the paper. And the last limitation or disadvantages is that even the best GPT like GPT-4 or Gemini 1.5 Pro or Ultra, it still has limited capability in math and reasoning. So these are basically these are the limitations of the LLM to judge other LLM, because even that, as a judge, it doesn't have a true knowledge or ground truth to work with. All right, so here is the MT benchmark that you can browse an example of the prompt. So let's see. Okay, we are going to a pairwise comparison. Okay, let me actually increase the size. Okay, pairwise comparisons. We have different tasks. Let's say we are looking at the math task, and this is one of the tests. In this test, this is it's about vertices of a triangle. So the user asks, the vertices of a triangle are at points 0, 0, -1, and 3, 3. What is the area of the triangle? And right now in this format, we are comparing Llama 2 70 billion parameters chat with GPT 3.5 Turbo. So each of these models will answer to the user queries, and we'll ask a follow-up question to both of them and see how they are going to respond. I'm not going to go through how these models answer to the prompts. I'm just showing you the setup of this is what the context looked like when we give it to the judging LLM. So yeah, we start with a user query. We have two models responses, and we ask follow-up questions, and then we get the response from the two models as well. And this is a reference solution. We provide a reference, the right answer to the LLM, the judge LLM, so it knows how to rank the model. So yeah, this is the template of a pairwise comparison that the judging LLM will see. The judging LLM will have an instructions of how it should be, or the system prompt. It should act as an impartial judge to evaluate the quality of the responses, blah blah blah. This is how the prompt looks like. The user questions, the original question is inserted here, and you have model A's or assistance A's answer right here, model B's assistance answer right there. You can also modify this to have follow-up questions as well. From the paper, this is the how it looks like. It's similar to what I showed you in the browser. So this is the questions. You have model A response and model B's response. You have follow-up questions. This is probably crafted by a human. Then from the follow-up questions, you have the answer from the model A, and you have the answer from the model B. And after giving this to the LLM as a judge, in this case it's a GPT-4. GPT-4 will analyze that, okay, assistant A provide incorrect response, it's repetitive and lacks clarity in this example. And on the other hand, model B provided relevant and accurate response. It says that the examples are clear, so it concludes that assistant B is more helpful, relevant, and detailed. Yeah, so this is a technique, empty bench. Basically, it uses LLM as a judge. Oops. Alright, so just to remind you, in this Chatbot Arena, in the full dashboard, there are three things: Chatbot Arena, empty bench, and MMLU benchmark. Now, we just talked about empty bench. We are going to go into MMLU, and the last one we are going to play with the Chatbot Arena itself. So, what is MMLU? MMLU comes from this work, Measuring Massive Multitask Language Understanding. MMLU actually stands for Massive Multitask Language Understanding itself. In this, it's actually a benchmark of a lot of questions and answers. In this paper, it says it has covered 57 tasks, but to clarify, this is actually subjects. There are 57 subjects in this benchmark, starting with like abstract algebra, astronomy, biology, different levels of biology like college biology and high school biology, even management, marketing, philosophy, history, foreign U.S. foreign policies. So these are 57 subjects that the LLM will be tested upon if you are using the MMLU benchmark. So when they say MMLU task, they actually means knowledge in these subjects. So if the model have good MMLU score, it means that they excel at these subjects like philosophy or nutrition or whatever. So yeah, these are what actually the MMLU benchmark tested: extensive world knowledge and some kind of problem solving capabilities, because the MMLU will be tested against physics, philosophy, so they need to actually know or capable of doing some problem solving. This is what the test looks like. It has this one is from microeconomics. This is the questions. The model will see the questions and multiple choices, and it needs to pick the right one. Here, one of the reasons that the government discourages and regulates monopolies is that ... A, producer surplus is lost and consumer surplus is gained, and so on. And the right answer is consumer surplus is lost with higher prices and lower levels of output. So when the model reads through this choices or options, it's starting with picking the wrong answer. But then when we train the model well enough, or the model knows enough from other sources like Wikipedia, it should be able to pick the right choice, number D, for example. So yeah, and this is what the MMLU looks like. So make sure that when you heard about MMLU tasks, it actually means answering this type of questions from 57 subjects: economics, mathematics, physics, history, philosophy, for example. You can go to this paper with code website. Actually, let's just go there right now. So yeah, this is paper with code website. It has codes, papers, research papers, and in this case, it has MMLU benchmark or leaderboard as well. On the x-axis, you see the years, right? And the blue dot and solid lines actually are the best in class at that particular point in time. So right now, the best model that can actually solve the MMLU benchmark is the Gemini Ultra. 1.76 trillion parameters, guys. It's really, really huge. Right here, Gemini Ultra. It beats Claude 3 by about 2 points. But whoa, what's the size of the Claude 3 Opus? Can I see? Okay. Oh, right here. Well, I actually don't know, but I think this is my guess. Claude 3 size is not as big as the Gemini Ultra. 1.76 trillion, guys. This is huge. Anyway, so that's the winner. But look at that. Gemini and GPT-4, the difference is 4 points. Is that significant? I don't know. It depends on your application, right? If your application needs to do really well at these one of these topics, maybe that's the right model for you. Especially if you want to excel, if you want the model to actually do really well across all these subjects, then you can use a Gemini Ultra, right? As maybe this is a guess, if you are building a tutorial chatbot for high school students, this is a good benchmark that you need to evaluate your models against. Okay, now this is a fun one. We are going to cover the last thing on the full dashboard. So this is a Chatbot Arena leaderboard that you can actually access for free. It's hosted on Hugging Face. You can go on Hugging Face and go to LMSys, and then you can come to this dashboard like a Chatbot Arena. There are two tabs here: the arena itself, in which the model is going to be ranked by humans, and then the final ranking will be done by ELO framework or rating framework. So right now with the Chatbot Arena ELO framework, Claude 3 comes on top. It actually wins against GPT-4, which is very interesting to me. And yeah, seems like it's doing really well. And Claude 3 even beats Gemini Pro. But you can also see that there are how many votes are there. So this is about, so this says that, okay, we have about 37,000 70,000 chat comparisons that Claude 3 has received, so that it gets to this point. The more the better, right? The more votes mean the more engagement. It's going to come to a maybe like universal consensus better. If the vote is like maybe less than 100, I don't think it's reliable. But now we are seeing quite a lot of votes, so it should be reliable. So yeah, you can see all other models here from OpenAI, from Google. Mistral is here. Mistral Large is at number 8 for this chatbot. If you come to a full chatbot, you have links to MT Bench that I just showed you, and MMLU benchmark as well. And again, in the full dashboard, each model will have the Arena ELO, MT Bench, and MMLU scores. Not all the models have all of these ratings. Some of them do, like a GPT-4, for example. You have the MMLU. The Gemini Ultra is here because it's not tested. I think it's not tested with the Chatbot Arena. All right, let's get to the Chatbot Arena. You can click this link and it will actually pop up right here. Let me just refresh this so that it's more live. Okay, it's not good. Okay, let's just close it here then. Click this one. Loading. Agreed. Okay, this is the arena. It has a battle sign, right? Crossing swords. So it's going to compare or have model A pit against model B. So you can do it right now. The model is randomly chosen. You don't see it, and you should not try to reveal it. Otherwise, this chat or this board will be cancelled, right? So yeah, ask any questions to anonymous model. Continue chatting until you identify your winner. If the model identity is revealed by any means during the conversation, it's going to be cancelled. This one is not counted. Okay, let's do something. So I have some prompts that I'm interested to see how the model's response. So I'm going to ask it like, if it's acting like an advisor in AI career, how would you recommend someone who is not currently in the AI field to prepare to enter the AI job, right? So here it is. I'm going to put my prompt here. I don't know what models A is actually, and I don't know what model B is. Okay, too many text. Wow, it's a long read for me. Here it is. Okay, I'm focusing on model A answers right now. Absolutely, I would be happy to provide some guidance on preparing for an AI-related job, education, get a strong foundation in math, computer science, essential like linear algebra, calculus, probability programming, Python. It's actually pretty good. A master degree in related fields like computer science should be enough. This is good. Now, do I have anything related to education for model B? It only says get a strong foundation in mathematics programming. It's mathematics, so it's okay, mathematics programming like here. Back to model A. Number 2 is learn about AI and machine engineering from okay, Coursera, edX, good. What about this? Take online courses. Same thing, but it actually specified or narrowed down the topic for me, Introduction to AI or Machine Learning by Andrew Ng. It even specified a legendary in this field. Do I have anything here? No. Okay. Third one, gain practical experience. It actually asked me to participate in AI learning projects, coursework, internship. Do we have anything here? Consider the no. Here actually yes. Participate in competition and projects. Kaggle. Yeah, good name. More specific to the point. Okay. Fourth, stay updated. Rapidly going field. How? Keep learning about new developments, tools, and technique. Is there anything similar here? Read research paper and blogs. It's actually pretty useful here. Read resources like or papers from OpenAI and DeepMind. Join the AI community. This is good. Mention LinkedIn community. Okay, you know what? For now, I like model B more because it provides me with more specific terms like Andrew Ng, Coursera, Kaggle, OpenAI, DeepMind. So I actually know where to look at rather than a very vague thing from model B. Okay, now I am going to ask it to create a descriptive and actionable career development plan. Is it here? Okay. How does it look like? Okay. So from the look of it, I think I like model B better still. It could be because this follow-up answer is related to the first answer it gave me, right? Because this is a chat. It involves conversation. So I'm trying to be impartial here. Okay, model A says, assess current skill set and knowledge. Nothing specific there. Set a clear goal. Well, ask me to get SMART goals, specific, measurable, achievable, relevant, and time-bound. That's good technique. Create a learning plan based on your assessment and goals. Create a learning plan. Should include theoretical knowledge and practical experience. Very generic. Build a strong foundation. Foundation in mathematics. Okay. Learn about AI and machine learning. Gain practical experience. Stay updated. Very, very generic and vague. Special. Okay. Okay. That's it. Now move to model B. Oh wow! Look at that. Step 1: develop fundamental foundation skills. 1 to 6 months. Complete online courses. Programming Python. Oh wow! Ask me for commitment too. 10 hours a week. Very helpful. Step 2: build AI related knowledge. By Andrew Ng. Specialized course. Okay. This is okay. Gain practical experience. Participate in Kaggle. At least 2 personal projects. Wow, number. Very specific, right? Even more specific than this. Alright, stay current and network. Read paper. Join AI community. Okay, this is good. Pursue higher education. Apply for master and blah blah blah. Apply for AI related jobs. So 2 months. 2 months. Did they ask for 2 months? Sorry, not 2 months. 2 years. Goal. Give me a goal that I can achieve in 2 years. You know what? B is really much better. All right. Wow. Okay. No surprise there. GPT-4 versus Databricks model. Here, this is how it works, guys. You can come to the chat arena. You can give it some task. Actually, you are testing it on an open-ended questions, and then you evaluate the model and you submit it. Now, this will be one of the votes, and in this case, this is going to be one of the votes towards GPT-4 versus Model A. Aside from this battle, you can actually, similar to what we have done before, but you know the identity of the model. You can come to this page. You can see the model side by side, but there's no fun in that. I'm going to skip it. You can also directly chat with the model right here, right? Well, this is for free. You can have a chat. So Claude 3 is known for being safe, not going to yell at you, as I have shown before. Let me just play with it. Screw you. Say to my face. Would it do that? Should not. See, this is a typical Claude 3. For example, can't do anything. Cannot do anything insulting to anyone. Let me try something else. Grok is not here. Let's try extra large. Same prompt. Oh, command you. I forgot to do that. Ooh. Okay. Moderation. Your input violates our consent moderation guidelines. Sure, fair enough. Anyway, so you can directly chat with the model in LLM's Chat Arena. Also, it has vision models as well, but I'm not going to go into that at the moment. Okay, I want to show you a few things. At the bottom, they are actually having statistics that you can compare model A against model B. So this is a fraction how much the model A wins for all non-ties of A versus B battle. The way to read it is that if I want to see GPT-4 against Claude 3, I can pick GPT-4 on the y-axis. It's right here, and I need to look for Claude 3 on the on the row. So this is where it is. This is GPT-4 against Claude 3. So this is a win, right? GPT-4 wins by about 49% of the time compared to Claude 3. So actually Claude 3 wins just for a little bit. This figure is a fraction of wins, but you need to also look to how many votes or how many counts that these models fight against, right? Which is in this plot over here. It's too small for you, isn't it? Can I zoom? Let's see. Zoom in. Okay. All right. So, okay. The way to read it is here. Oh, okay. I can win. So I can zoom. Actually, so this GPT-4 is pit against Mistral Medium, and there are 781 votes, right? So this is number of the competition or the comparison it receives. The more, the better, as I mentioned. How do I do that? Okay. Damn it. Oops. So let me try to zoom in. Reset is right here. So yeah, if you see the not many votes like here, so can I focus? Oh, I can actually zoom in here. Auto scales. In this case right here, Mistral Large against Claude 2. It's only 17 votes. I'm not going to trust the win rates in this plot because there's too few votes to rely upon. That's how you read it. So if you're comparing two models, mostly you are going to look into very famous model, very good quality like GPT-4, Claude 3, Gemini Pro, and so on. You can come to this plot and see how much which model A wins against model B. But don't forget to check the votes, right, as well. At the bottom, they also have ratings or scores, right? And you can actually, this is very interesting, you can see performance classes. Top A classes are Claude 3, GPT-4, and another GPT-4 as well. Gemini Ultra is not in here because I think this platform doesn't have access to Gemini Ultra just yet, so it's not in there. But if it's there, I think it should be somewhere here. And you have the second tier models like Bard or Gemini Pro, Claude, Sonnet, GPT, another GPT-4 right here. Even Haiku, Cloud 3 Haiku is there. Mistral Large is in the second tier model. So yeah, so this is the Chatbot Arena presented by LMSys. Okay, we are ready for the second topic. But before we are diving to there, let me just remind you again, if you like what we are doing, subscribe to our channel. Okay, the second topic is about tokenization. What is tokenization? Tokenization is essentially a way to translating the input text that human can read into something that the LLM understands, which is a series of what we call tokens. Tokens. Token is represented by a number, right? Maybe a word I is a number 101. Maybe a word cat is 102. And with that number or token number, like 100 or 102, we can convert it to something that the large language model will understand. Essentially, LLM model will have its own dictionary of tokens, right? It can be like a model that is capable, will have a vocabulary as big as 300,000 tokens in its dictionary. Whatever tokens not in that dictionary will be tagged as an unknown. So maybe in the world of the actual world of human languages, we might be able to have 500,000 tokens, but if the vocabulary is only 300 tokens, therefore 200 human language token will be collapsed into just an unknown token for the LLM to understand. Basically, each LLM model will need its own dictionary of tokens, and tokenization is a process of translating human language text into a series of tokens inside that LLM's dictionary. Well, as a concrete example, this is a human-readable tokens, right? This is a token for starting the message. This is a system. You are a helpful assistant. And start user. Write a Pythonic function called multiply A by B N. So this is a human readable input text. And I just highlight the token when it's been tokenized for you, right? This is one token that the LLM will see. This is another token. So you will see this is the tokens, right? I'm going to show you how this works in a few minutes, but I want to talk about why this is important. There are many tokenization techniques like byte pair encoding or BPE, which is very commonly used these days. It's very high performance, but other techniques exist in natural language processing like word piece or sentence piece. If you are using API, for example, Vertex AI API from Google or OpenAI or Claude 3 API, you will be charged by token counts. So that's the important aspect to know. If you are using tokens by API, you will be charged by token count. Different tokenizers or returns different or returns the input text differently into different tokens, and therefore different token counts. But the most important thing is, if you are developing your own app or LLM application, you need to choose the right tokenizer for a chosen LLM. An LLM will need to be paired with its matching tokenizer. Otherwise, you will get a gibberish answer, because it's like you are using a wrong dictionary for a wrong LLM. And also, you need to keep track of your token users in your app, because you are going to get charged by that. So if you are thinking of charging your app user, LLM app users by tokens, you need to count that, right? Let's say if for 1,000 or million tokens, your API provider, for example, OpenAI, for 1 million tokens, you get charged by $10. This is just some made-up number. Then you need to count how many tokens you are using, so that you can charge your clients by token count, right? You can quote, okay, to your customers that we are we are providing a service that for 1 million tokens, it's $15, for example. Okay, now we are going to talk about Token library. But actually, before going to the library, I need to show you how you can play with this tokenization in the website. You can come to this website. Tokenizer.verso.app is a tokenizer that works with OpenAI models. You can pick your models or embedding models here. So you have text search Da Vinci, you have GPT-3.5, GPT-4, the encoders, I'll talk about this later, but you have many models from OpenAI to see. Okay, and you have a chance to construct conversations and count how many tokens will be there and prices as well. But let's take a look at this example. I'm going to go back to my slide to actually put this. I am going to put this in that website. Write a Pythonic function called multiply AB. Write a Pythonic function called multiply AB. This is how it looks like. This is the matched message, the human-readable message that will be sent into a tokenizer, and this tokenizer is specialized for or is matching to GPT 3.5 Turbo only. By this tokenizer, this whole thing here has 27 tokens in it. This is one token. As you see, you can see it's highlighted. This is another token. This is another token, right? Now, you might think, okay, tokenizer is just splitting a sentence into words. Not necessarily. Look at this. It's splitting Pythonic, it's a word, into two tokens, Python and IC. Now, IC happens many times in English language or English words, right? And usually it signifies that this thing with an IC at the end will make it an adjective, right? So this is tokenization. You are trying to break word and apparent word into subwords, in which a subword can be applied in generalization. And another interesting thing here is that this multiply underscore A underscore B is supposed to be a name, right? This is a name. But because maybe it's not in the training data set of the tokenizer, it doesn't know this is a name just yet. It's trying to break it down into many components like multiply underscore A and underscore B. Anyway, it's a way to break words into subword. What if I change the model? If I change the model, say to GPT-4, how does it look like? It looks even more difficult to read, right? But again, there are 25 token counts. You see, when I change the tokenizer, it's the same message, the token count changed. Now, what is happening here? I'm trying to see if I can detect what's changed. But I'm too lazy to do that. What if I pick embedding model? Is there any embedding model here? Right here, text embedding adder 2. Okay, write a Pythonic function. Did I call function? Yeah. function called multiply AB. Same thing happened with Python nick, right? It split into Python and ick, and the same thing to multiply. Okay, this is tokenization, meaning you have human readable text. It will be converted into a series of tokens. These are tokens, and each token is represented by an integer or a number. Now, I want to show you TikToken library by OpenAI. TikToken library is a fast open source Python tokenizer. It works in Python, but if you want to use it in other languages like C++ or Java, I think there are libraries provided by OpenAI as well. You can Google it, you can search it and look into OpenAI cookbook about TikToken, and you will find more information. As I mentioned, you need to pick the right tokenizer to the right model. There is a way to do that very easily with the TikToken library. So here, this is a way. If you are going to use a GPT-3.5 Turbo as your LLM, you can say, TikToken, get me the encoding for this model, and you'll get the right encoding model for your application. It's say fast. In this website, well, it's on its GitHub, it compares itself with the tokenizer from Hugging Face, and you can see the throughput that is so much different. The throughput is on the y-axis. At the maximum, like 16 thread count, it almost reaching 40 megabit per second here. But again, the performance is quite different from the Hugging Face open source tokenization. Now, just to give you a complete overview, encoding schemes is like it's a way to split words into tokens. These are called encoding schemes or encoding names. Different encodings apply to different OpenAI models. They keep improving. Here, CL100K base should be used for GPT-4, 3.5 Turbo, embedding adder, embedding 3, the latest embedding model from OpenAI. So this is the, I guess, is the latest encoding scheme for TikToken. GPT-2 is 50K, R52K base. And you also have like P50K base as well. Codex is a model that is very good at giving you coding assistance, is using P50K base. For me, I'm not going to remember what it is. I am going to use this one to give me the right embedding. And this library, TikToken, is also extendable, meaning that you can use it and you can add new tokens to the library so that you can perhaps train your own or fine-tune your own language models with your own new tokens. As an example here, a new token is merged into the library by using this pattern or syntax. Alright, so it's time for coding exercise to show you actually how TikToken works. Okay, I have everything here. Let me just clear all the outputs, increase the size, connect my collab. Okay, it's connecting to, again, Google's infrastructure. Maybe taking a few seconds to do. The first thing first, make sure that I have OpenAI library and TikToken library installed. So I'm going to run that through. Also, I have my OpenAI API key kept in this tab here. the secret key and I activate it, or I enable it for this notebook. So yeah, make sure that you have your OpenAI API key and copy and paste in here, and you can load it up using this syntax. So I'm just going to go back to a table of content. So right now I'm running this code to load up the OpenAI API key. I am going to then import tick token library, and this is one way to get an encoding if you know what encoding scheme you use, or you can use, as I say, get me the right model, get me the right tokenizer. I'm using this model, so I prefer this one. It's easier to make sure that it's right. Okay, now I have my encoder, or the tokenizer if you will, right here. Okay, this is the basic usage. Let's say that I have an input which is in human language, is a Pythonic code. I am going to encode it. Encoding is actually, or tokenizing it is encoding. It's essentially translating human language to a token, right? So I call the tokenizer encode the input for me, and I have this, right? I have a series of tokens represented in integer for me. Now, a tokenizer also has a way to decode, meaning translating the series of text back into human language. You can do that by calling a decode method and input your series of tokens right there. So I get Pythonic code back after decoding it. Now, if you want to decode just one integer, you need to use this function, decode single token byte. It's more reliable to convert an integer to an integer token to a human language subword. And you can see here 3 tokens that I have from the tokenization of a word, of a sentence, Pythonic code. I convert it back. I got 3 things: Python, ig, and code. And that's it. You convert an integer back to a human language, but it's in the byte form. Anyway, with this technique, if you have a tokenizer, you tokenize your human language input. You can easily count using this function length. Okay, I am going to show you more example. So I need a function. This function is called process. It will take an input and a tokenizer. It will print what the input is. It will convert the input into a series of tokens. Then it will print how many tokens are there. And then it will print how many, what are those token integers. And then what I'm doing next is I'm converting each token into back into human language, but it's in byte. And then I'm converting a byte into a string in the UTF format. So here it is. I divided my process right here. So I'm going to test with a test and test. Not very creative, am I? Alright, the input is test and test. There are 3 tokens, which are this: 1985, 323, and 1986. Very strange. See? Test and test. I don't need to reason. I think this is an algorithm inside a tokenizer. I don't need to reason. It's different. 1985 and 1296 is different. Could be because there's space over there, but whatever it is, it's there. Alright, next one. My input is Batman man will do anything else, will do a Batman-y thing. I'm interested how it will be tokenized. Here, it has 10 tokens in it. This is a token Batman. Man will do a bat any thing. So yeah, Batmany. This is not a typical word. It's now the tokenizer is now split it into bat, any. I don't know. It's just the way it does things. What about non-English language? Let's say a Thai language. This word means two words. Non-English languages, like Thai language, for example, it will be tokenized by character rather than subwords. For example, here, this is one character, another character, or even a vowel. One vowel is also tokenized into its own thing. What if you have, I keep clicking on it. What if you have two languages in an input? Let's say this could be a prompt to ChatGPT or Gemini. Translate this to English. How does it look like? The tokenizer recognizes English, translate as a word, so it's actually put one token in it. But then the bracket is one token, and non-English language, like Thai language, is now split in character, similar to what we had before, and the rest is typical. So yes, so the tokenizer kind of handles everything inside it. Non-English, English languages, brackets, symbols, it handles everything for you. What about misspelling? Now, I dropped the S, pretending to misspell my input text. The effect is that the tokenizing or the misspelled word might be tokenized differently from the actually correctly spelled word. Like here, translate now is split into tr and late. So tokenizer itself doesn't care or doesn't know that you misspells a word, but the large language model will understand that. It will try to correct, or it will try to understand what should be. So if I can show you, I'm sure if you put that sentence into ChatGPT, it will be able to translate it back to two words, for example. Hey, what about math? How does it handle? So I have some kind of programmatic word for maths. This is the integrate x squared dx. How does it do it? So it tokenized into int x exponential 2 and dx. Good for me. What about a more difficult syntax? Like maybe this is something to give to a ChatGPT. Find this. The derivative of this thing inside a bracket is an exponential of x squared plus x by dx. How is it going to do? This is what it has tokenized for me. Find is fine. The exponential x by dx, this one token, and dx. Not sure if it's going to do. Do I have ChatGPT over here? Sorry, I don't have. Chat OpenAI. Well, haven't logged in yet. Or maybe next time. Okay, what if you ask it to describe a function? This can be done by ChatGPT for sure, right? Here it is. The input is this one. 18 tokens, you have described the following function, new line, def symbol print, the name is split into 2, the argument is split even more, and you have that, the rest. So now you have seen a lot of cases that the tokenizer will see in probably your real world application, like misspelling, math codes, non-English languages, like translations, a combination of English and non-English languages, or even like combination of languages. You've seen many cases now, and the tokenizers will handle everything for you. Okay, the last topic in this section is going to be about counting your tokens when you use OpenAI API Call. So let's import the OpenAI, specify my API key, and create a communication client. Here, this is a message that I want to send to the OpenAI system. As a system, you will need to be, you are a helpful assistant. You will assist the user in a polite, helpful, and harmless way. And then a role of a user, that's a message. A message is given to this one, and I will get my response back from the client, and I'll get my response out to this notebook. So yeah, I have defined my get completion code. What is my input again? My input is this. Describe the following function. Essentially, this one. This is my input. So I am basically asking OpenAI GPT to describe this function for me, and I will receive my response very soon. So I have received my response, in which it actually answer me here. I received this one from OpenAI. This function is named simple print, and it takes one parameter, x. It simply prints the value x to the console and then returns none. This is correct. It doesn't perform any complex operations. It just prints the value of x. This is correct. What I don't like is that it doesn't really use good grammar here. How do you concatenate two sentences with a comma? Am I wrong? Anyway, so this is this is the whole response that I get back. The user, when you are building your app, you just want to show this to your client. Oops, I need to, how do I do that? Message. Okay, what am I doing wrong? Oh, choice. Sorry, I need to call choice. OICE, choices. 0, 1, 0, right? Message. Okay, choices. Alright, what is happening to me? Chat completion is not so. Okay. Oh. Here. 0. And okay. Well, all right. This is it. If you want to just send a message to your app user, you just need to access this. But if you want to count the prompt, it's right here. It's in usage key, right? And they are actually all these here. So your prompts, essentially this one, it has 49 tokens, and the return count is 51 tokens, and total tokens is 100 tokens. You might want to separate the completions or the response tokens from the input or the prompt tokens, because input prompts and output prompts, they are charged differently. The output prompts are charged more, right? So basically now you have means to keep count of how many input tokens you provide and how many output tokens you received. All right, this is it for tokenization. Again, if you feel this is useful, please subscribe to our channel. If you have any comments or questions, don't forget to put it there in the comment section as well, and I will be happy to answer to your questions. Before we leave this topic, BPE, or the byte pair encoding, is very, very popular these days, and it has very good performance. If you want to have a deep dive, I recommend going to this website. It has very detailed explanation of this topic. Also, you will be able to see YouTube video from one of the legendary in AI, Andre Kapathy. He will be talking about TikTok tokenizers, because he works at OpenAI, right? So he actually does a lot of this thing. Okay, now it's very exciting time for the third topic, which is in which we are going to build a customer chatbot. And our situation, let's say that we are running a coffee shop and we want to build a chatbot to answer to our customers who might be searching to our stores online and want to know what we have before they come to our stores. So in this example, or this case, you will see LangChain, Chroma, and Gradio in action in order to build a RAG chatbot. But before we go in there, previously in our last episode, we mentioned the concept of RAG, which stands for retrieval-augmented generation. In RAG, there are 3 steps: indexing, pretty much preparing vector embedding database for search, digesting your or ingesting your documents in here, and the second step is retrieval, where you receive a query from the user and you search inside your vector embeddings database to get the right context. And then in the last step, you build your final prompt, inserting the context for grounding, and then you ask the LLM, maybe a Gemini Pro or ChatGPT, to actually create the final response. For more detail, go back to episode 4. We dived into all the tiny bits of this algorithm, so you can actually see how it actually works underneath. But for now, we are going to go to coding for this. Alright, our case is that we are running a coffee shop and we want to have a chatbot that can answer to our questions. So in order to do RAG chatbot, you need documents, and I have created several documents so that I can serve my customers with my chatbot. My documents are contained here. The first one is the general info of my coffee shop. So I say my shop name is Planet Box. What we sell coffee, drinks, and coffee beans. Our operating time is here, Monday to Friday, 7 a.m. to 8 p.m. Saturday, Sunday, or national holidays will be 9 a.m. to 4 p.m. The address is, sorry, this is a misunderstanding. Anyway, so the address, maybe this is a headquarter, address is here. Branch number 1 is at Icon Siam Mall, Thailand, Bangkok. Branch 2 is on the 103rd floor of the Empire State Building. Hypothetical, of course. And the way we can receive payments is by cash, credit card, Square, or even Bitcoin. So this is general info for my store. I also have my drinks menu. My drinks menu, this one can be done, it's actually done in, do you have a review here? No, it's actually done in a CSV format. So table of drinks menu is here. Coffee, espresso, americano, cappuccino, latte, and mocha. Small size prices and large size prices are there. Table for add-on items or change. If you add ice, that will be more, 50 cents more. Oat milk is $1 more, and soy milk is 75 cents more. So this is, if you think of a business, having or putting things in a table is easier for a small business to handle, right? So we are going to test if we do this, if we keep some small tables in a CSV format, will the RAG system understands it. Now, these are drinks menu, right? I also say we have beans as well, and here these are tables of beans. We have 3 types of coffee beans: Geisha, Yogurt Chef, and Blue Mountains, and Sumatra Manhelling. 4 types of beans, and this table contains a compact information about these beans: origin, altitude, flavor profile, acidity, body, aftertaste, processing method, roast level, recommended brewing, even offering packagings, right? Like how many grams and how much we sell for, certification of these beans, and awards of these beans that we sell. These are hypothetical. Everything is hypothetical here. But not only that, I have a compact CSV table to compare these beans, I also have fact sheets for each of them. Let's take a look at one of them. This is Geisha, Geisha coffee beans with the fancy names. I'm not sure how to pronounce it. Hacienda La Esmeralda. And in these fact sheets, I have origins, altitude, test profile, processing, roast level, brewing, packaging, prices. Actually, it's very detailed. In one of them, I make up this case, right? So I asked ChatGPT-4 to create this fact sheets for me. 4 of them, all of them, will have the same fields or attributes for these fact sheets here. And what I actually did is I asked ChatGPT to go through of these 4 of them and create a compact table that you have seen here. So I have 2 levels, right? The first one is levels that is ready to compare, for the model to compare, which is a table, but I have a detailed level in which it's a specific document, very detailed, a detailed fact sheet for each of the beans. So these are my setup. My store has general information for the stores in a document. I have menus that I have for sales, like drinks, and I have coffee beans menus. I also have fact sheets for each coffee beans. So I want to have a chatbot that can go through all these documents so that it can answer to different users' questions. Now, the first step of the RAG system is create an index, right? Okay, let me clear all for you. I am selecting my kernel. Alright, so I am importing we are going through the indexing steps at the moment. So I am importing my keys here. I kept my key in my file. Not the best practice, but it's easier for me to demonstrate. I also have, now I am creating an instance of the model that I will use to embed the text. Now I'm using LangChain. LangChain also has an integration with OpenAI models. So with LangChain, I can access OpenAI model easily this way. It also has a way to load a text for me from a file. Now, in this section, I'm going to prepare a list of what files I need. Basically, I point out to a base folder, documents, and I'm going to list through all the files and eliminate or exclude something that I don't want in these files, right? Here it is. After running this code, I should have a list of files that I want here. You can see it's correct. The price, menu of the drinks, general info, coffee bean menu, and all of these 4 fact sheets for my beans. So now what I'm going to do is I'm going to prepare a document instance that I will use later, and in this way I am preparing a document by using a text loader from LangChain, which I have imported right here. Now the loader instance will load a document and I append it into a list. Here it actually went through all these files one by one, load a text into an instance and add that instance into a document. So essentially, documents is a list of document instance in it, and if we are going to take a look into what each document is, let's say looking at the first one, it's type of document. It's one of the class in LangChain library, but in this one you have page content. What is inside that page, right? Inside content. So this is price menu, which is this guy. Don't forget that this guy is in CSV file. So now it has coffee table there, comma, new line. So this is like CSV format, right? And everything is contained here up until soy milk. So my menu file is loaded into a single document right here. Document also has metadata. You can actually manually edit this metadata or add more, right? You can add change a source. If you don't want to have an absolute path, you can change it into a relative path yourself. Anyway, so this is what document looks like. We are loading everything now. Everything, all the files here is in memory in each of the documents instance right here. Now the next step is we are going to index it, and when I index it, I want to keep it in a vector embedding database. I am going to use Chroma. Again, LangChain has an integration with Chroma library, and this is a way to actually use Chroma library. Now, if you have documents loaded, it's very easy, very easy to create an embedding database using this syntax. Chroma from document, and then you provide a document. You specify the embedding model that you will use, which I have already defined it right here. I'm going to use OpenAI embedding. I can specify what type of OpenAI embeddings I would like to use, maybe text embedding adder or text embedding 3. I recommend you use text embedding 3. It's better, cheaper. But I haven't specified right now. You can do that later. What I'm going to do is I just use as default value that LangChain OpenAI library provided. So I also specify that after you have created the embedding, keep it here. I will keep it into the folder Chroma, and I specify the collection name Planet. Collection name helps the vetting, maybe helping the vector embedding database section what kind of information you keep there. So I have run this notebook before, so I test everything is right. Now I am going to remove this so you see what is happening. Okay, new terminal. I'm here, so I am going to remove everything. It's gone. Chroma library folder is now gone. Alright, so I am going to run this section, create an embedding and store it. Now, because I'm using an API, these texts will need to be sent to OpenAI server, and then I receive the vector embedding back. That's why it takes quite some time, 7 seconds, almost 8 seconds here. And now that you know, notice that your vector embedding database is created right here. To make sure that everything persists in my local folder, I execute this one more. That's it. You have created an embedding database for your RAG application. Now it's time to try retrieval. The second step is retrieval. Alright. Okay, let me clear all the output here. Kernel is right. So again, we are going to use the LangChain as the main library, but it has again integration to OpenAI models, Chroma vector embedding database. So I'm loading the module that I want. I am creating the embedding instance again. The reason is that I need to give the same, I need to give it when I want to reload my embedding database back. This is a way to reload my embedding database back from this folder. So the important thing for you to do here is make sure that your embedding model, when you load it, is the same embedding model that you use to create the embedding. Otherwise, you are going to have a gibberish result here. Okay, now this is my embedding database loaded. Let's go through how to use this vector embedding database, especially the Chroma. We are using the Chroma library. So when we have the embedding database, called DB for now, you can search. Let's say that the query, the user is asking about opening hours. What you can do is you can use a function or a method called similarity search with relevance score, and you put your query here. The returns is the following. Let's print result. Essentially, the embedding database will search for relevant documents. The default value is that it will provide up to maximum of 4 documents, relevance documents. And now because I asked for relevant scores, I can see my relevant scores here. So it will put the most relevant document first. How is it relevant? So the query is opening hours. And as I actually know, it should be contained in this general info text, which is right, because take a look. General info text start with shop name, Planet Box, and you see that this page content is this one, right? And the relevance score is very high there. Now you can reduce the number of the return documents by using an argument k. If I want only 2 documents, now I get 2 documents, right? And here we go. I only get 2 documents back. This is similarity search. So as I mentioned, you are comparing, as I mentioned in the last episode we are actually comparing how close a vector is. So a query vector emitting and the document vector emitting, you compute similarity by a dot product as an example. And this is one of the way. Chroma has another another way to search called maximum marginal relevance. It's essentially a way to iteratively find documents that is dissimilar to the previous results. Let's say that the algorithm finds the first most similar or most relevant document, then the next one that it will suggest, it will try to find the best one iteratively. And there are papers showing that using MMR provides a better search result. The way to use it is very simple. You just call max marginal relevance search, and you can also limit the number of the return results using a k argument as well. Here comes the first argument. The first document is this one, shop name, and the second document somehow is been changed to, or the algorithm has decided this one is more relevant to the query. The query is opening hours. Okay, this section shows you how to use a similarity search and the MMR search. The result is that you'll get relevant documents. From this Chroma, you can also get a retriever instance. You can do this. db.asRetriever. You can also specify search type. In this case, I specified the MMR, in which I can then further provide more conditions for this MMR search using this search keywords argument keywords. Alright, with this I have my retriever. It's an object, right? And the way to use a retriever is to use an invoke method. So if you do that, you will essentially get the same result here. Not quite the same, isn't it? Now let's change the second document to there. The reason why I use retriever rather than doing this is because this is a low-level function that you can use if you custom make everything. Now the reason that I'm showing you retriever is that now we are ready to build a chatbot. Alright, so this is a second step. Retrieval step is done. We are moving to the third one, generating answer. But better yet, we are going to use agent-based chat. We will make an agent. Agent is a large language model that can use tools or converse with a customer. So imagine this. You have a chat that this chatbot is capable of conversing with a customer. Small talks, for example. But when the chatbot is asked for specific details like store information or beans, it will reach a tool. It will use a tool that we will provide to it, and that tool is a RAG tool, retrieval-augmented generation tool, and this tool will provide a document, a relevant document to the chatbot to answer to specific questions. It might seem very complicated, but with LangChain library, we can just easily do an agentic chatbot or agent-based chatbot. Alright, so I am importing everything that I need right here. Also, similar to what before, I created my embedding instance because I am going to load up my vector embedding database Chroma using this line of code. Now we are going to create some RAG tools. This is going to be a tool that the Agent LLM will use. We can easily do that by using this function, create retriever tool. What it needs is this one, DB provide a retriever, and for this one I can specify as before, I'm going to use the MMR search. Now this tool is named Planet Box Search. Imagine if you are having many tools. Maybe this is Planet Box Search tool for your chatbot. What if your chatbot will be integrated with an ordering system and payment systems that allows a customer to order and pay for the coffee and pick up at the stores? You will need a specific tools to communicate with an ordering system or payment gateways, right? So a name and a description will actually help an agent LLM to pick the right tool to use. So the name here is Planet Box Search, and description is that search for information about Planet Box store, including general information, coffee drink menus, specialty coffee bean menus, and bean fact sheets. Alright, I have defined my tools. Now I am going to create my agent. First thing is, what's the brain of my agent? I am using GPT-3.5 Turbo as my agent's brain, or the LLM. And this is my system message. I instruct the brain to be like this. You are a helpful assistant working at a coffee shop. You can use a given chat history or given tools to respond to a user. Your character is a polite and friendly female. Maybe important, I don't know. You answer concisely without introduction or appending anything to make it more concise, right? If you do not know the answer, just say, I don't know. And when you all calculate the price of an order system, you should think step by step. I added this because when I created this one to demo, I found that it actually cannot give the right price for my mocha smalls, but using oat milk instead of just typical milk. So I added that. I'm not sure if it's going to help or not because I haven't tried it yet. Anyway, this is a system message. Now, it's going to a little bit more complicated here, but essentially this prompt is needed to create an agent. And the prompt is structured in such a way that it's actually a chat prompt template for which we start with a system prompt to prime the agent to act accordingly. And then we have a message history, a placeholder for the chat history here. And then we are going to have a place for a human input to be in here, right here. And the last one, this is a place for an agent to think what should be the right step, what tool should they need. Everything is here. This is just a structure or boilerplate, you just need to use it. Now, this is the tools that I would give to my LLM to use, my agent to use. Currently, there is only one tool, the RAG tool. Here we go. Everything is ready. Now I am going to create my agent. This is the brain of my agent, the LLM, GPT-3.5. This is the tool that I give it, and this is the prompt, the behavior. I also define memory so that I can see what is happening inside. And eventually, there is a convenient function called Agent Executor, where it will create everything for you. You just need to pass in the agent, the tools again, and I want it to spit out what it's actually doing, and provide explicitly provide the memory for the agent executor to keep log of what is happening. Here we go. Everything is ready. And because I want to show you in chat format in Gradio, this is a way of creating very quick and dirty chatbot interface with Gradio. In order to do that, you need to create a function. That function will return an output from a bot, but it has two other things inside. It needs to have a chat history, so I need to create a wrapper so that a chat history is in a way that Gradio likes. So yeah, I don't want to go into the detail, but these are two helper functions that will allows me to launch this chat user interface. Okay, I can use it here, or I can actually try to, oh, does it work? Oh, it does. See? Okay. Let me, hang on, let me try to move it right here. Here we go. Alright, this is the chatbot that we just created. Okay, I pretend that I am a customer who has found this coffee shop online. Let me ask, when are you open? By the way, keep in mind that this is this is GPT 3.5 at the back end. Oh, correctly? When are you open? Monday to Friday, 7 to 8 p.m. and Saturday, Sunday, national holiday, 9 p.m. to 4 p.m. Is it correct? Yes, it is. What's the name of your shop? I pretend that I misspell it. Planet Box. Good, this is correct as well. Now, are you open now? I don't know. You know what? Because the LLM doesn't know what now is. So this is one drawback of this simple system. It's just a retrieval-augmented generation system. It doesn't have tools to retrieve the current time. So it doesn't know. This is the right answer, but not a good system to handle this type of answer, right? Okay. Where are you located? Not know. Okay. Where is branch? What? See, where are you located? I think the agent thinks that I'm asking the agent not about the store. That's why it's answering I don't know. What if I ask, where is your shop located? How is it going to answer? That is correct. The headquarters is here, the cloud, the G floor of the M Quartier in Bangkok. But as usual, okay, I will just need to come back to, where is it? Here. Okay. In the general info, I have a few branches here, right? Let's see if it can recall that. Where are other? Do you have other location? How is it going to do? I'm excited. Good. It recognized that there are 3 locations, even though it's a mix of languages like Thai and English, for example. All right, let's ask about coffee beans. or maybe actually coffee drinks. What do you sell? Sell coffee drinks and coffee beans. Tell me more. Okay, you have a variety of coffee drinks, espresso, americano. How much are they? They give you the whole menu, but actually it misses two. It has actually missed 2 more coffee beans, right? So that's one of the drawback. So I need to improve my system afterwards. Okay, how much is mocha with oat milk? So mocha itself, small mocha is $4, and oat milk is actually $1 extra. It should answer 5. So yeah, this is still wrong. So I need to fix this. Again, this is RAG tool. It's not a calculator tool. And also because I'm using GPT-3.5, maybe it doesn't know better. Maybe you will get a better answer or more correct answer if you use GPT-4. Right? You see, there are many components that you need to change. You can improve. For example, how about coffee beans? Okay, so I think it actually thinks that I'm still asking about price, so it gives me the prices here. What? Let me just see. What spatial the beans do you have? Okay, only 3 beans. So this is really not correct. But again, I am going to improve it later. But let's say if I like fruity and sour coffee, what bean should I buy? You should buy Yirgacheffe coffee beans, as they have fruity and sour note. Is it correct? I'm curious. Okay, let's go to Yirgacheffe. Test profile: floral, bouquet, citrus twist, lemon. Maybe it's associated fruity with floral and being sour with lemon. I'm looking at Blue Mountain profile right now, so it's sweetie herb, right? Why am I looking here? I should be looking at here. So profile, Yirgacheffe is lemon, right? This is not likely sour, sweet, herb, nutty. So yeah, Yirgacheffe could be the right answer. If I ask it for sweet and chocolate, it should give me Blue Mountain, right? What beans? Geisha. Sweet and chocolate test profile. Is it doable? Is it okay? Geisha. Geisha. Test profile: jasmine, bergamot, peach, berries, acidity, we like it sweet. Oh, maybe it's struck with a sweet thing. Anyhow, so let me ask, can I pay by cash? Should be yes, right? Can I pay with crypto? It doesn't know crypto, right? But can I pay with Bitcoin? Yes, okay. So yeah, I think with just these basic setups, you can see that the RAG tool or the agent, the LLM can answer some specific questions by retrieving the documents that we give it to them. Okay. So because we are asking functions to the agent to actually verbose its thinking, later on you can come in here and see what is happening. So yeah, right now we start, just remember, we start with store hours. It has retrieved this document as a context, and now with that it provide an answer. And when we ask about location, location, somehow it has retrieved it here. Retrieve this document first, but this the second document comes after, is here, and it actually used this one. It's decided that it will use this document to answer, right? What else? Yes, we have. So if you ask it to verbose, you can actually see what is actually thinking, and then you can debug your performance later. Oh, yeah, all right, guys. This is it. You have seen how we have built a chatbot with RAG, and you actually see how we use LangChain and Chroma vector embedding database and build a very quick and dirty interface with Gradio. So to summarize for today we have covered how we are going to how should we hire an LLM to do our job, to do our task, right? Essentially it comes down to evaluating the LLM right. And you have seen 3 ways of doing that. Chatbot Arena is basically human voting and use an algorithm to rank the LLM. You can now see which model is winning over another model. You know what is called the empty bench, or a technique that is called is actually used. LLM as a judge is a way to scale up and scale up your evaluation, and provides with some explanation as well. So in this way, GPT-4 or perhaps Gemini Pro Ultra can be a judge for you. And you understand what the MMLU means. It has 57 tasks, but actually it's not a task, it's actually subjects like histories, physics, biology, philosophy. So it's actually a benchmark to test the LLM for world knowledge and problem-solving capabilities, right? The second topic is about tokenization. Now you know what it is. It's essentially transforming human readable text to a series of sequence tokens that the LLM understands. And this is essential because it will have an impact on your LLM app, right? And you saw how to use TikToken library, which is an open source fast library for from OpenAI. And lastly, you have seen how to build a chatbot that can interact with customers and answer some generic questions using RAG tools, right? RAG tool allows you to retrieve documents, and with retrieval as a tool, your LLM can retrieve the information, answer to the user correctly, and also being an agent, it can interact small talk with the customer as well. We just know that with only RAG tool, it's functional, but it's not perfect. It cannot compute. It doesn't have, if you use the small LLM, it might not be able to do a calculation right. But again, RAG is just one of the tools that you can give the agent to do it. And with this, demo, you know how to use LangChain, you see how to use Chroma, and you know how to do very quick and dirty interface with Gradio. So this is it for today. Thank you very much for staying up to now. If you have any comments, please provide to the YouTube channel here, or any questions at all, like RAG tools and whatever it is. Give us a comment, and if you want to know other kinds of use cases, or you can ask me what kind of use cases that these AI tool can use, you can ask it via the comment as well. And last but not least, subscribe to our channel and spread the word. Tell your friends about it if it's actually helpful. Thank you very much. Enjoy your day.